This is section 2.1, part A, describing locations in a distribution. One way to describe the location of a piece of data within a distribution is called the percentile. The pth percentile of a distribution is the value with p% of the observations less than that. So if we say something is in the 40th percentile, that means 40% of the data fall below the point of interest. It is impossible to be in the 100th percentile because your value cannot be larger than 100% of the data. Use the scores of Mr. Pryor's first statistics test to find the percentile for the students. So Norman scored 72. So we need to see first how many students took the test. If you count the data points, there are 25 students who took the test. And we need to see how many students scored lower than a 72%. If you look at the stem plot, 72 is right here. So there's only one score that is less than a 72. So 1 out of the 25 students scored below a 72%, which is 0.04 or 4%. So that means Norman is in the 4th percentile. Katie scored a 93. Again, we know there are 25 students. We want to see how many of those students scored below Katie's score. So the 93 is right here, which is the very last score, which means all 24 of the other students scored below her. So even though Katie got the highest grade in the class, she is only in the 96th percentile because 96% of the class scored below her. She cannot score above her own score, so she cannot get in the 100th percentile. The two students who scored an 80. So here are our two students who scored an 80. Again, there are 25 students total. We need to see how many of them scored below an 80. So if you count up all the students who scored below an 80, there were 12 of them, which gives us 48%, or the two students who scored an 80 are both in the 48th percentile. Frequency is the total of how many times a category occurs. And relative frequency is when the frequency of a category is divided by the total frequency for the set value and then turned into a percent. So frequency is basically just the count. It's telling you how frequently something happens. And then the relative frequency is saying, in relative to the entire group, what percent of the time does this category occur? So if we look at 40 to 44-year-olds, it happened 2 times. Now, there were 44 observations altogether, so 2 times out of the 44 says 4.5% of the people in the entire observation were in the age group of 40 to 44. Now, a cumulative frequency is the sum of all the frequencies in the specific category and all the categories that come before it. The last category will always be the same as the total. So and then we can do the same thing with cumulative relative frequency. That would just be the percent. So if we have 2 as our frequency here, then the cumulative frequency is 2 because it's all the values up to that. If we have 7 in the next one, 2 and 7 together give us 9. So we're saying everyone up to age 49, there are 9 of them. In the 50 to 54-year-olds, we have 13 people. So all people up to age 54, we would add all those categories together, and you are up to 22. The cumulative relative frequency is, again, just taking whatever cumulative frequency you have and dividing it by the total number of observations. The very last one should be 100, and the very last of the cumulative frequency should be the total for the entire category. A cumulative relative frequency graph is a graph that plots a point corresponding to the cumulative relative frequency in each class at the smallest value of the next class. It is customary to start a cumulative relative frequency graph with a point at a height of 0% at the smallest value of the first class. The last point we plot should be at a height of 100% and should be at a class that is larger than the last data value. So the table we looked at previously, right here, this is talking about the age of presidents when they were inaugurated. So our first group goes from 40 to 44. We will start the 40 at 0, and we will end the 44 at the 2. So we start at 0. At 44, we would be at the 2. So the next one starts at 45, and so on and so forth. Our last data point on the table is at 69. So since the last data point is at 69, we need to end our graph higher than that. So they end the graph at 70 for 100%. So we need to interpret a cumulative relative frequency graph. What can we learn from the cumulative relative frequency graph? From this graph, we can see where the slope is shallow, where the slope is the steepest. So the graph grows very gradually at first because there are very few presidents who were inaugurated in their 40s. So the slope isn't really great in these two sections. Then when we jump to the 50s, this slope is much steeper because most presidents were inaugurated in their 50s. After that, the steepness of the graph goes down again because there are less presidents who were in their 60s or above when they were inaugurated. So the steeper the slope, the more occurrences there will have in that category. Why does the graph get very steep beginning at age 50? As we discussed on that previous slide, most U.S. presidents were in their 50s when they were inaugurated, so the rapid growth is shown by how steep the graph is, and then it slows down again at the 60s. Could we figure out what percent of presidents were between 55 and 59 years old at their inauguration? So we can see at age 60, if we take this over, we are about 77%. And at age 55, if we take that over, we are at about 50%. So between those two ages, between 59 and 55, we would just need to subtract those. So we have 77%, we have 50% before that. We just want to find out the little bit between these two. And if we subtract, you should get about 27% of the U.S. presidents were inaugurated between the ages of 55 and 59. Was Barack Obama, who was inaugurated at age 47, unusually young? So if we look at the graph for age 47, that would be about here. If we take that over, that looks like it's halfway between 0 and 20, so that'd be about the 10th percent or the 10th percentile. So based on the graph, we estimate that Obama's inauguration age places him at about the 10th percentile, 10th cumulative relative frequency mark. So he was about the 10th percentile of the distribution. So it is not completely unusual, but he is one of the younger presidents who were inaugurated. Estimate and interpret the 65th percentile of the distribution. So if we have 70 here, 65th would be about here. We take it over, we see where it hits the graph, and then we come down, and we could estimate that to be about 58 years old. Have you made the connection between the percentile and the quartiles from Chapter 1? The median, which is the second quartile, corresponds to 50th percentile because 50% of the data falls below the median. The first quartile, or the Q1, has 25% of the data below it, so it's the 25th percentile. And the third quartile, or Q3, has 75% of the data below, so it is the 75th percentile. Now let's check our understanding. Mark receives a score report detailing his performance on a statewide test. On the math section, Mark earns a raw score of 39, which places him at the 68th percentile. This means that Mark did better than about 68% of the students who took the test. Mrs. Munson is concerned about her daughter's height and weight compared to those of other girls of the same age. She uses an online calculator to determine that her daughter is at the 87th percentile for weight and 67th percentile for height. Explain to Mrs. Munson what this means. So this means of girls who are the same age as her daughter is weighs more than 87% of the girls in the same age group, and she is taller than 67% of the girls in the same age group. The graph displays the cumulative relative frequency of the length of phone calls made for the mathematics department office at the high school last month. About what percent of calls lasted less than 30 minutes and what was more than 30 minutes. So if we go to 30 minutes on our graph, we go up, we see where it hits, we go over, and we can see about 65% of the calls lasted less than 30 minutes. We know this is 100% total, so 65% lasted less than 30 minutes. That leaves 35% lasting more than 30 minutes. We need to estimate the Q1, Q3, and find the IQR. Now, as we just previously stated, the Q1 is at the 25th percentile. So if we go over from the 25th percentile, go down, the Q1 is at around the 14-minute mark. And our Q3 is at 75%. So if we go over and we go down, the Q3 is at about the 32-minute mark. So remember, to find the IQR, we do our Q3 minus Q1, which in this case will be 32 minus 14, which gives us 18 minutes for our IQR. And remember, the IQR tells you the range or the spread of the middle 50% of the data.